In this video, I'm going to demonstrate reducing a fraction by identifying the greatest common factor that both the upper number and the lower number share. To do this, I'm going to start with a factor tree of both the numbers involved. I'm going to break the numbers 84 and 120 up into any two factors that multiply to make the original numbers. So on the side, I could try dividing 84 by just various low natural numbers such as 2, 3, and 4, and so on. What I'm looking for is, does this come out to a whole number? We want to look at those results, and if we see a case where the result of dividing gives us a whole number, then we know that 2 is a factor of 84, and even 42 is a factor of 84 as well. When we divide 84 by 3, we get again a whole number, which means both 3 and 28 are factors of 84. If, on the other hand, we divide by a certain number and get a decimal, that means that 5 is not a factor of 84. So we just have to pick one of these combinations to break 84 down. I could go with this first one, 2 and 42. Since 2 times 42 makes 84, they are a valid combination to put at the ends of the branches of this tree. Now 2 we see is prime, and that means it has no factors that it could break down into other than itself and 1. It wouldn't be helpful to continue this tree because this could keep going forever, and there's really just no reason to do it, so we don't do that. We just stop whenever we get to a prime number. 42 is not prime though. We can break it down into two factors other than itself and 1. I noticed that the thing is even, so I might choose to divide it by 2 on my calculator. If I do 42 divided by 2, I get 21, and so I want to put that 21 here in the tree. 2 is prime, but 21 is composite, meaning it has more factors than just itself and 1. So let's break it up. You could try 21 divided by 2, but that comes out to 10.5, which means that 2 is not a factor of 21. Instead, we could try the next natural number, 3, and on calculator we see that that does result in a whole number. Therefore, we can put the combination 3 and 7 there, and now we're done with the tree. We've arrived at all prime numbers. We could even write the prime factorization. 2 times 2 times 3 times 7 makes 84. Let's try this same process for 120. If I divide 120 by 2, I'll get 60. 2 is prime, but with 60 we can keep going. Two numbers that I can think of that multiply to 60 would be 6 and 10. So I'm going to put those here as part of my tree. Neither of these is prime, so we're going to keep going with both of them. 6 is going to break up into 2 times 3. Those are both prime. And 10 will break into 2 times 5. These are prime as well. If we want to write the prime factorization of 120, it would be 2 times 2 times 2 times 3 times 5. Now the reason why I did this is I'm looking for the greatest common factor. ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... ... So what is the greatest common factor going to be? What we want to do is we want to look in the factorizations for things that they share. We see that 84 has a 2 in its prime factorization, and 120 has a 2 as well. These can be seen in the tree here and here. And so 2 is going to be part of the greatest common factor of these numbers. But there could be more to it than just that. We want to look for anything else that they might share. I see that both 84 and 120 have another 2 in their factorizations. We could identify that in the tree here and here. And so that's going to be part of our greatest common factor as well. Is there anything else that they share in common? I see one more thing. They share a 3. So let's include a 3 as part of the GCF greatest common factor. At this point, we can multiply to find out what that is as a number. It's 12. So 12 is the greatest common factor of 84 and 120. What we'll do now is take that original fraction, 84 over 120, and we're going to divide both the top and bottom by a number. The number that we're going to use is the GCF. This is a factor that they both have in common, that both will be divisible by in a nice way. So we're going to do 84 over 120, divide that top number by 12, and divide the bottom number by 12 as well. So let's do that on calculator. We're going to get 7 on top and 10 on bottom. Because we divided by the greatest common factor, this fraction in the end will not be further reducible. And it is the final answer to the question.